So we're going to be working with exponent multiplication a little bit later. So we just want to make sure we understand how to multiply exponents together. So basically exponents are repeated multiplication. So if I have 2 times 2, I can show it as 2 squared. Okay, 5 times 5 times 5 is 5 cubed. We can express, as long as the bases are the same, we can express as an exponent. So 3 times 3, I can express as one exponent. 7 times 7 times 7 times 7 can be expressed as another exponent. Okay, now it's important to understand that exponents cannot be used with addition, subtraction. They're not compatible. So one thing that I want you guys to understand is this bigger idea. We have plus and minus, okay? And there's times and divide. These two things are actually compatible. Okay, we can mix those. Now we don't want to if we can avoid it, but we can mix those in that we can distribute multiplication over addition. Okay, so we can have like 3 times x plus a, and we can deal with the times and the plus at the same time by doing that. Okay, 3x plus 3a. Okay, now there's also exponents and roots, and they go together. Okay, they're inverses of each other, so they go together. And although times and divide and exponents are different, right, they are compatible in that they can work together. Okay, so if we have something 3 times x squared, there's a power and a times in there, I can actually do this, 3 squared times x squared. Okay, and that's okay. These are check, check. What cannot happen is multiplication and, exponents and addition subtraction do not go together. There is no connection here. Okay, we don't want to connect the two. Multiplication and exponents, addition, subtraction, and exponents should be kept separate from each other. Okay, and when we see it, we just don't do anything with it. We don't try to mix them together. And I'll give you a good example here, which I see all the time. If I have add and exponents, I often see people do this, a squared plus b squared. Okay, this cannot happen, okay, because powers and addition subtraction do not mix. Okay, they do not go together. There's no algebra that connects them. So we want to make sure that we understand there's addition, subtraction, multiplication, division, powers, and roots. And if we just take one step, there we can connect between one step, but between addition, subtraction, and powers, we do not want to connect those two things together. There's the algebra that you do for those is going to be wrong. Okay, so we want to make sure that we're very careful about that. Okay, so we can write these expressions in one exponent by just counting up the multiplication. So 1, 2, 3, 4. Okay, we're using the base 5. We're using it as an multiplication 4 times. So we show it this way. This is no longer a times problem. It's an exponent problem. Here we have the base 2 used 3 times. Here, although we don't know what this number is, we know we use it in multiplication 1, 2, 3, 4, 5 times. Okay, so we use the base A 5 times. And again, there's no longer times or addition, subtraction. Now we're talking about different mathematics. Okay, we're talking powers. Here we have 5 used 3 times. And we have the number 2 used 2 times. But they're not the same base, so we have to connect it with multiplication. Now, we've now mixed some math. We've mixed powers with times, and that's okay, because they're not separated by 2 steps like we have here. Okay, they're connected to each other, so there is ways to do it. They're not the same thing, but we can at least combine them together. Here we have 3 to the power 3, then we have our plus. We can't count across that plus, and we have 3 to the power 2. Now, this is a problem here. We cannot do anything with this. Nothing. Okay, because now we have powers and plus. This is it. There's no mixing of this somehow. Magic that happens, because that magic is wrong. Okay, we cannot start mixing powers and pluses together. Okay, so what's some rules about repeated multiplication of the exponents? So if we have positive power, that is repeated multiplication, and we count. Okay, if we have negative power, well, if positive is repeated multiplication, negative should be repeated division. Okay, how often do we divide by that base? Okay, and we also know that times, and we can take away times from divide. Or subtract, right? We can take away times with a divide. Okay, so these are some rules that we can use with multiplication. Okay,